Welcome to another Mr. Paul video. Today we are discussing 7.1 and we're finally able to reach equations with variables on both sides. And we can think of equations with variables on both sides as the one step and the two step, but this time we're going to add a third step, meaning we need to accomplish all three goals when solving these equations, okay? So what does it mean to be an equation with variables on both sides? Well, this is an example of an equation with variables on both sides. So let's refresh ourselves what our goals are, what some of the terminology is. When we say we want the variables on both sides, on one side of the equation, remember this is our first goal. The variables are the stuff with the x's, right? We're keeping in mind this is the stuff with the x's. And we can identify the variables as stuff with x's. Okay? And when we say we want the constants on the other side of the number, we mean more like the regular numbers, right? The regular numbers, the numbers that we know and love. The numbers on this number line, we mean the 3 and the -7. So our first goal was to get the variables on the one side of the equation and to get the constants on the other. So as you can see by the colors that I've chosen, I have variables on both sides of the equation marked in green so you can see it, and you have constants on both sides of the equation as denoted in blue. And my goal with these first two steps is to separate them. I want the blue side to be I want one side of the equation to be all blue and the other side to be all green. And that would mean that I have all my constants on one side of the equation, all my variables on the other. Okay? So what I'm trying to do with this first goal is I'm taking a look at this situation and I want to decide, do I want my variables on the left-hand side of the equation or do I want them on the right? And it's a fair question, but at the end of the day, it doesn't matter. Okay, now let me explain. I'm first going to solve this problem if I was to take them and put them on the right. Okay, which means I'm taking them off of the left. And you'll see that we'll come to a conclusion and that the math may be different for putting the variables onto the left and the constants onto the right, but the math may be different. I'll put them side by side, but the end goal will be, the end product will be the same. Let me show you what I mean. For this first example, I'm going to suppose I want the green things on the right, meaning all of the variables I want on the right. So I'm going to erase these colors so I can do some math here. But I want to move the variables onto one side of the equation. I'm choosing to put them on the right, which means I don't want them on the left. I have to get rid of 7x. We've talked about inverse operations. This is positive 7x, so I'm going to take away 7x. Okay? I'm doing math with just variables. If I do the same thing to both sides are equal. 7x take away 7x, that cancels. And I'm left with plus 3. I didn't touch -7. And then on this side, I wanted to take away 7x so that I could say both sides are equal. I'm taking away something from both sides. I'm taking away 7x from both sides. 9 take away 7 is 2. So I have plus 2x's. I still have positive 2x's. Okay? After goal 1 has been accomplished, you'll notice that the variables, right, the stuff with the x's are on the left, or the right, excuse me, and the constants are on both sides still. But goal 1 has now been accomplished. You'll notice that 2x is a variable, and there's no variables left on the right, on the left-hand side. They're all moved to the left. Now, my second goal is I want my constants on the other, meaning I have this blue on both sides. The regular numbers are on both sides. I don't want them on both sides. I want them onto the opposite side of the variable. So which means I don't want this -7 there. Okay, let me erase these colors so we can see some math happening. I don't want this -7 here. I want it on the opposite side of the equation. So using inverse operations, if it's -7, I will add 7 to this side of the equation. If I do, I have to add 7 to the opposite side of the equation to maintain that both sides are equal. The result is 3 plus 7 is 10. And negative 7 plus 7, those cancel, and all that's left on this side is 2x. You'll notice that I have the constant on the left and the variable on the right. They are now successfully separated, and that's what I want. I want them separated from each other. That's what the purpose of these two goals are. Now, my third goal is to get to where 1x is equal to something. You'll notice that I have 2x's are worth 10. I don't want 2x's, I want 1x. So which means I have 2 times some number is equal to 10. I don't want 2 times that number. That number is being multiplied. I want to get rid of the 2 by dividing it. If it's being multiplied, I divide it. It's divided by 2 because it was being multiplied by 2. I'm using the opposite operation. Whatever I do to one side, I have to do to the other. If I do, I can maintain that both sides are equal. 2x, 2 times x divided by 2. 2 divided by 2 is 1, so I have 1 times x. 10 divided by 2 is 5. 1x is equal to 5. And this is the solution that I'm looking for. I know that on one side of the equation, I have one single x. And because I know what the equal sign means equal in value to, I know that the value of x must be equal to 5. And what does that mean? It means when x is 5 in the original equation, both sides will be equal. So I can imagine this as a 5, and I can imagine this as a 5, this x and this x. 7 times 5 is 35 plus 3. 35 plus 3 is 38. This side is equal to 38 when x is equal to 5. 9 times 5 is 45. 45 plus a negative 7. 45 plus a negative 7 is 38. When x is equal to 5, this side of the equation is equal to this side of the equation. Okay? We mentioned earlier, what if we did it wrong? What if we put the variables on the wrong side? And I want to address that moment here. So let me block this off just a little bit. Let me make myself a little bit of room here. Let me block this off so we can show some writing here. I'm going to do the exact same problem and show you that this works out the exact same way, even though it looks a little bit different. So once again, we have 7x plus 3 equals negative 7 plus 9x. It's the exact same problem, except for this time we had the variables. We moved the variables to the left-hand side. What happens if we move them to the right? Which means I'm going to do the same exact process, but what happens if I chose the opposite side? So instead of taking away 7x, meaning I'm removing it, I'm going to remove the 9x. So I'm going to take away 9x's from this side. Whatever I do to one side, I'm going to do to the other. And if I do, what's the result? Well, 7 take away 9 is negative 2x. I didn't touch the 3, so it's still there. Didn't touch negative 7, it's still there. And this plus 9 minus 9 goes away. The same goal was accomplished, except for my variables are on the right. The variables are on the left, and I have constants on both sides, just like I did here. I now want to get the constants onto the opposite side. The variables are on the left. I need my regular numbers on the right. This is being added. I will now subtract 3 from both sides to maintain that both sides are equal. Negative 2x is left. The 3's cancel. That's equal to negative 7 take away 3 is negative 10. Okay? Negative 2 times x is equal to negative 10. I don't want negative 2 times x. I want 1x. So I have to, these are being multiplied, so I have to divide. Not by positive 2, but by negative 2. Remember, I'm dividing by the exact same number because I want 1x. Divide this side by negative 2 as well. If I do, both sides remain equal. Negative 2 divided by negative 2 is 1x. Negative 10 divided by negative 2. Remember our trick, 10 divided by 2 is 5. If the signs are the same, it's positive. This is a positive 5. So this is 1x is equal to 5. You'll notice that both 1x and 1x, 5 and 5, both of the 1x is equal to 5 and 5 equals 1x are equivalent statements. Those are the same thing. Both of these are telling me that the value of x is equal to 5. The value of x is equal to 5. The question is, does it matter which one I do? Well, no, it doesn't matter. I will say this. Is there a better option? I like dealing with positive numbers. You'll notice there's a lot of dividing by negative. I'm having to do a negative, take away another negative number. I don't like dealing with so many negatives. I personally make more mistakes when I deal with negatives. So if I'm planning ahead, I could think to myself, well, would I rather take away 9 or would I rather take away 7? Knowing the process, the first step would lead to a positive value for x, if I did it, is a great first step to think about, although it doesn't matter which side you do. That's just my personal preference. Okay? So we're not going to be doing both ways for the following examples. Okay? I will do 2 more examples. We'll just do the way that nets us the positive values. We like dealing with positives far more than we like doing with negatives. And I'll help you decide which way will make positive math versus dealing with a bunch of negatives in math. Okay? So let's erase these and let's go on to example 2. And maybe we can move just a little bit faster because we don't have to explain each step. We just understand the goals of getting variables onto one side of the equation and getting our constants onto the other. So our next example will be (3 minus 4x is equal to negative 3 minus 3x. Okay? You'll notice, I'm not going to underline it this time, but you'll notice that I have a variable on the left, a variable on the right, and a variable on the left. I have a constant on the right and a constant on the left. I've got constant and variables on both sides. My first step is to get variables onto one side of the equation. Now I have a choice, the left side or the right side. Well, do I want to add 4x or do I want to add 3x? I personally think adding 4 would give me a better result. If I added 3 to both sides, sure, I'll get rid of this, but this will still be negative. If I add 4, I will get rid of this, and this will turn positive. It'll turn from a negative number to a positive number. I'm thinking ahead. Which variable would I like to cancel out, and what would the result be? So although I have my choice, add 3 or add 4 to both sides, I'm going to choose the 4 because when I cancel the 4, this becomes a positive number. If I were to choose the 3, if I add 3 to both sides, this negative 4 plus 3 is still a negative number, and I don't want to deal with negative numbers. So I'm going to add 4x instead. I want to add 4x to both sides. Okay? And if I do, what's the result? Well, this negative 4x plus 4x goes away. I'm left with just 3 is equal to 3 on this side, and then negative 3. Negative 3 plus 4 is plus 1x. Okay? Goal 1 has been accomplished. I have variables on one side, but I still have constants on 2 sides, which means I need to get the constants onto the opposite side. I do not want this negative 3 here. I will add 3 to both sides, choosing to cancel this 3 because I want them all on the opposite side. Well, on this right-hand side, negative 3 plus 3, they cancel. I'll have just 1x left. And because I did the same thing to both sides, 3 plus 3 is 6. 1x is equal to 6. My goal 3, 1x is equal to something. You'll notice that goal 3 has already been accomplished. Goal 3 has already been accomplished. I have 1x equals to something, which is what drives us mad about algebra. Not all problems are the exact same. Sometimes steps are skipped because the goal has already been accomplished. Sometimes we finished early. Sometimes there's extra things we have to do. Okay? So we just have to be patient and make sure that we're separating the variables from the constants and dividing or multiplying down to get to 1x. And if it's already at 1x, what this means is when x is equal to 6, both sides are equal. Okay? Let's do one more example for this video. Suppose we have 3x plus 9 equals 1x plus 10. Nope, sorry, 19. Okay? We have variables on two sides, constants on two sides. We want to get the variables onto one side. And again, my decision on which side I want to put them on, is it the left, is it the right? Well, if I want to cancel them from the right, I'm going to subtract 1x, which means I'll be subtracting 1x from here and subtracting 1x from here. What would happen? This would cancel. 3 minus 1 is 2. If I decide to cancel it from this side and subtract 3x from this side and subtract 3x from this side, what would happen? This would cancel. 1 take away 3 is negative 2. I'm now at negative values of x, and I don't want that. Although it doesn't matter, I'm going to stick with positive values because it makes my life easier. So I think I want to take away 1. I'm going to take away 1x from both sides. So subtract 1x from both sides, and I'm subtracting because it's positive. Okay, remember the opposite operations? 1 minus 1, they cancel. I did the same thing to both sides. So 3x take away 1x is just 2x. I didn't touch this plus 19, so the plus 19 is still there, and so is this plus 9. Goal 1 is now been accomplished. I canceled it from the right, and what remained was on the left. Now I want the constants onto the opposite side, meaning I want this 9 gone. It's being added, so I'll subtract. Subtract 9 from both sides. 2x, these cancel, so we have 2x on one side, and that's equal to 19 minus 9 is 10. I now have variables on one side, the constants on the opposite. Goal 1 and goal 2 have been accomplished. I now want 1x is equal to something. 2 times x. I don't want 2 times x. I want just 1. So if it's being multiplied, I will divide by the exact same number, 2. X is being multiplied by 2, so I will divide it by 2. Whatever I do to one side, I will do to the other to maintain that both sides are equal. 1x, because 2 divided by 2 is 1, and then 10 divided by 2 is 5. What this is saying is when x is equal to 5, both sides of this equation are equal. 5. 3 times 5 is 15. 15 plus 9 is 24. When x is equal to 5, 5 plus 19 is equal to 24. Again, I know if I did this correctly, if I use what I suppose the value of x is, and both sides of the equation are equal when x is equal to whatever you think it is. I know this subject's very confusing. Make sure that you watch the 2 videos before this if using inverse operations was something that was confusing to you. We'll have many more examples of this in class and during the subsequent lessons. That's all for today's video. Peace.